Okay, so hi everyone, Senan on this side, and let us solve this course schedule problem on LeetCode. And the question is asking basically you are given a number of courses and you have to take labeled. Okay, so basically courses are labeled from 0 to number of courses minus 1. You are given an array of prerequisites where prerequisite I is AI, comma BI indicates that you must take course BI first if you want to take course AI. Okay, so let's see. So for example, if the pair 01 indicates that take course 0, you first have to take course 1. Okay, so you have to return true if you can finish all the courses, otherwise you return false. So in this case, the first test case, number of courses is equal to 2, prerequisites is 1 comma 0, output is true. There are total of 2 courses to take, and you can take either first take 1. To take course 1 you have to finish course 0, so you take 0, then you can just take 1. And so if you think properly, okay, before that, you see this case there is a cyclic dependency. For 1 you have 0, for 0 you need to have so okay, so what do you do? So first of all, if you think properly, this could be a graph problem. And what type of graph problem? If you carefully observe, you need to have one before the other, and this would hint you directly to having a topological sort, and that is the case. This is a topological sorting question. So if you don't know how to do the topological sort, watch my previous video just before this one, and you'd get the idea what I'm trying to do. So I won't be discussing the exact logic of the topological sort that we are going to implement. I can give you the idea, but this is what it. Okay, so let us see this, the solution, that how can you actually do it. So first of all, you take a vector of vector int, or basically this is your adjacency list, which has at max number of courses. So what you do is, these prerequisites are not just prerequisites, they are of this graph in a way. So if you take every edge, you get the start node and you get the end value. Edge of 0, edge of 1. Now for example, the pair 0 comma 1 indicates that to take course 0 you have to first take course 1. So that means 1 to 0 is a directed edge, right? So 1 should come before 0 in the ordering. So that is why for 1, the end node, we take the end node and we say that it has a directed edge towards this start node. That is, so 1 has a directed edge towards 0. And this is how you get the adjacency list given this number of courses and the prerequisites, which are basically the edges. Now the logic we are using is the Kahn's algorithm, and this uses a not a visited array but an in degree array. So what this is doing is calculating the in degree, and the logic of this Kahn's algorithm is you find all the nodes in degree 0, take that as a part of your solution, find all the edges that are connecting uh, or basically, so all the nodes that have in degree 0, what you do is you now hypothetically take that out of the graph. What you are left is the remaining graph, and you find the all the nodes have in degree as 0. You take that as a part of your answer and do this till the time you have an empty graph. So I brushed it up because I've covered this heavily in the past two videos. So past one video, the previous to that one is the depth first search approach of this. Okay, so what you do is you first take all the nodes in your queue which have in degree 0, and you define a vector sort, and if the queue is not empty, you take out the top element, you pop that out of the queue, and you take that node as a part of your solution, a topological sort. Now for all the edges, you see if now basically in this for loop you're trying to remove that node that's popped. So for all the neighbors of this node, if the in degree is greater than 0, what I do is I decrease the in degree, because since I'm taking out one node, I am taking out that edge as well, decrease the value of the in degree of that node, the neighbor node. Now if for some reason while removing this edge the in degree of this node becomes 0, that means now we can have this as a part of a solution. It has no more constraints left. So I take that element, I push that into my for loop. I push that into my queue in this for loop, and in the end, for some reason, topological sort dot size is not equal to number of courses. That means there was a cyclic dependency somewhere along the path, and that is why we were never able to get those nodes as a part of this if state. So in degree or cyclic can never be, because every node depends on the every other node in the. So we would never be pushing those elements in the queue. Since we are never pushing into the queue, we are never pushing them into the answer array, and if we are never pushing into the answer array, this size would be less than number of courses, and at that point we know there is a cyclic dependency. We just reject this, we say return false. Otherwise, if the topological sort is dot size is equal to number of, that means we never found a cyclic dependencies, and we were able to remove every node and have new nodes which had in degree as 0. We took that notes again, did this till the time we had an empty graph or the null graph, and if that is the case we return. So that is the whole video. Not much to explain, and we'll after this video I'll do the course schedule 2. So just a minor change from this, I would take the exactly same code, copy this, and we would I would meet you in the next, and thanks for watching.